Let's see. All right, so 41. This one's hard. Find an equation for, well, you know what, let's draw some stuff. Find an equation for a line that is tangent to the graph of e to the x. Okay, so e to the x, and I want a line that goes through the origin and is tangent. So I need to know the slope of the blue line and the coordinate where the blue and the red hit.
And find the derivative.
Okay. So do I know this coordinate? As a number, no. But so I need, it's some x. And what's the y value going to be? E to the x. Why do we know that? Because it needs to be on the red line as well as the blue line. Okay. So just using geometry, the slope of my tangent line is y minus y over x minus x. But Amir, you said you need to do the derivative. What's the derivative of the red line?
Yeah.
So the slope of the blue line and the immediate tangent at the red curve needed to be equal. So the slope of the curve is this guy. The slope of the straight line is that guy. And at whatever coordinate, this coordinate, these slopes need to be equal. So e to the x over x has to equal e to the x. What does that mean x is? Are we saying 1? If I cross multiply, and divide by e to the x, x is 1. And it says find the equation of the line. So, okay, y minus the y value equals slope. What is the slope at this point? What is the slope when x, we plug in 1? Is it just e times x minus the x value? X. Y equals e to the x, e times x, not e to the x. Yeah.
Why did you set this equal to each other, the e to the x over x and the e to the x over y?
Okay, because if I have a curve, the slope of the curve and the tangent line have to be the same right there. So I found the slope of the red line by doing the derivative, or Amir did that for us. And then I just did geometry with 2 coordinates for the blue line. And those slopes had to be equal. Yeah. 41's tricky. Yes,
Why is the slope just e and not e to the x? Oh, because you plug in 1 and it's at 1.
there you go. Thank you for answering your own question. Love it. Alex? It percolates a minute. Okay. Yeah.
Would the y value always be e to the x in this scenario, even if it didn't go through the order, right?
Yeah.
Okay, just making sure. Okay.
And they made the problem much more simple by saying, and it goes through 0, 0. Because plugging in zeros for things is nice.
Yeah.
Questions on any of these guys? Yeah.
And can you go to 37?
Yep. 37. I would do a lot more. I would do pre-cal first. Because again, I don't know the derivative pattern for this. Like I taught it yesterday. I don't ever use it. I would do change of base. First step. How do I change this base to be natural log?
Log of X over log.
I'm gonna call it ln. Base goes in the basement. Because doing the derivative of natural log is so much easier. Those guys cancel, so the derivative of this, Eitan, what's the derivative of natural log of x?
1 over x.
1 over x? Done. Anything else from this page? Yeah,
Could you go to the
33. Same thing. I don't do that other pattern. So natural log of the top over natural log of the base. Natural log of 2 is just that. That constant's going to stay there. So the derivative is 1 over stuff times derivative of stuff.
So is there never a time when we'll need to use that pattern, like we can just always use the change of place one?
Yeah, and I thought I said that yesterday. Like I don't know Olna. I don't know Olna. Mr. Orlando used to say Olna was this Swedish lady. Olna, she's going to teach you calculus. I don't know why she sounded like that, but she did. Yeah.
Can you go over 17, please?
Yep. Yeah. 17. And I don't remember if I told you guys yesterday, ender is just use your calculator to do the derivative to check to see if you got the same thing. Set 17. Okay. E to the stuff is e to the stuff. Preston, what is the derivative of 3 to the stuff?
Is that just a to the X?
Yep.
So is it a to the X times the other hand?
So 3 to the stuff is 3 to the stuff, and then there's the cost of like changing base. We need to multiply by the derivative of or natural log of the base. And Luke, what am I forgetting?
You chain rule for the exponent, which is negative cosecant cosecant.
And then chain rule of everyone's most hated trig function. Secant sucks, but cosecant's worse. It's negative, puts itself in its own derivative, and brings a friend. Its usual co-conspirator of cotangent. And they would probably rewrite this to bring the negative out front. I don't know where they would put the trig functions, but whatever. It's gross. That's it. Nothing simplifies.
U29.
Yep. $29, natural log of natural log. Ooh. Alright. So Sasha, how do we start? This one?
First, would you change ln(x) to 1 over x?
But Ellen, so doing some algebra or doing some calculus? What are we doing? First, okay, is this a power rule, a product rule? What's the outermost function?
It's
This is not a product. The outermost function is natural log. So how do we do the derivative of natural log of a? Well, it's 1 over a. And a in this case is natural log of x. So 1 over stuff. And then chain rule times derivative of stuff. So what is the derivative of the thing inside? Miriam, what's the derivative of this thing inside?
1 over x.
So it's 1 over x ln x. Yeah. Other issues? Let's see. Can you guys do number 30?
I'm good at this.
You're good at this?
Zoom in.
I'm bad at this.
Okay, well then we need practice. Try number 30.
Can you zoom in on it?
Oh, yeah.
Is x minus x in natural log, or is the negative x by itself?
Okay, how do you guys read that? Is the minus x inside with the natural log or not?
No, it's outside, right?
It's outside.
Okay.
There's no
If they wanted
parentheses.
it inside, they would have had to give you some parentheses, and then it would have been natural log of 0, which is not allowed. Okay, so Hadley just said, I'm gonna split it into the product rule and that guy. Okay, you're right. So what is the derivative of that product?
I got x times 1 over x and then times ln x.
Okay,
Oh,
so
plus ln x.
first times the derivative of the second, x times 1 over x plus second times the derivative of the first, which is
It's just ln x, right?
the derivative of the
Move
first is
on.
1, so it just, yeah. And now the derivative of negative x.
Minus
So this is 1 plus natural log of x minus 1.
This is ass.
So the reason I said to do this one is because, remember I warned you, going forward is easier than backwards. Doing the derivative is easier than the integration. You will eventually integrate this. So I saw this, I'm like, oh, I know what that is. I know it's derivative because I know the integration. Anyway, yeah.
I just factored out x, got the same answer. Will I get like some wrong? Was that a nice coincidence or like some wrong answer? If I do that somewhere else.
Dude, what?
Okay, so he wanted to do it this way.
Yeah, and then just
So-
product rule.
Product
those two
rule.
things. Yeah.
First times the derivative of the second plus second times the derivative of the first. It's another method, Amir, and it's fine. I don't see it being easier, but if that's the way you see it, that's fine. As long as whatever you do in the beginning, you're using some algebra.
I was
algebra
talking
two.
about the first method. Where'd you get the other ln x from? After you made it into a derivative 1 over x.
This guy,
Yeah, where'd you get the other ln x from?
this one.
The first method. The method beforehand.
Okay. Well, hold on. So as long as you do valid math ahead of time, and if you do too much like algebra or pre-cal, please remember to follow through and actually do the derivative. Okay, Amir, let's try this again. If we take this product,
Yeah.
how do you do product rule?
Product rule is you do the derivative of the first times the second times the
Okay,
derivative of
okay.
the second times the first.
Okay, you said derivative of the first, so what is, this is,
1.
and what do we do with the second?
We make it a derivative 1 over x.
Right here, right now?
What? What the f- do you mean?
Okay, Amir, product rule. Hold on.
Okay,
hold on.
ln x.
Product rule.
I know how ln x. I didn't need.
Okay, all right. Well, you said it wrong a second ago. So if you do the derivative of the first, leave the second alone. That's where the ln x comes from. Now plus the first
X
untouched.
times 1 over x.
So that's product rule.
Yes, yeah, thank you.
And then this guy was a -1.
Yeah, thank you.
Anytime. So that was the three. Was that all of it? Yeah.
This is kind of like a general question. With problems like 5 or 9, where there's like a constant or like e whatever being raised to a function with like x in it, is it gonna be like the outside part of the function is considered like e to whatever it's being raised to? It's not like e to the x is the derivative. It's like always gonna be just whatever the original, and then you multiply by the which is
Okay.
which is this one.
I think yes. So let's see. This one, it's e to the stuff. Derivative of e to the stuff is e to the stuff. And now derivative of stuff. What's the derivative of 2/3 x? 2/3. Done. There is one on here that's weird. Only one. Lily, what's 11? Pi is about 3, right?
Yeah.
So how would you do the derivative of x to the third?
Bring down product with subtract.
Okay, so is pi just a number?
Yeah.
So
It's pi x power pi minus 4.
gross. But it's just a number. Ew.
Yeah.
That one was just to irritate you. Did it work?
It made no.
No? Sure. Fiona, what about 13? 13.
It's the same do negative root two x minus, or like to the negative root two minus one.
Negative root two, it's gross, it's just a number, so multiply by the power, lower the power. All good? There were some other fun ones in this. But all of these with log base something weird, I would do the change of base first.
And we don't have to know the alternative.
As long as you can do the derivative of that. No, you don't need, like, if you do change of base, you only need derivative of natural log.
Okay.
Okay.
Okay, so 31 would just be like what? 1 over x squared ln 4? Like ln 4's to the bottom, right?
Let's see, Jamie, you weren't here yesterday. Did you see how to do these? Like from pre-cal, do you know how to do change of base?
Yeah.
Okay, so what is change of base for this?
Natural log x squared over natural.
Natural log of x squared over natural log of 4. And I'm gonna go one step more. I don't like that. But we can do the derivative of either piece. dy dx equals, if I do the derivative of this one, natural log of 4 is just a number, so it's still gonna be there as a constant. So the derivative of that is 1 over that times derivative of x squared. If I do that here, 2 over ln 4 is just the number. Derivative of natural log of x is 1 over x. This one is the same. This x and one of those x is reduced, and I get the same answer. Ethan?
So if there was a, if the base had a variable in it, would you have to do the quotient rule?
Oh, if the base had a variable in it, you're in trouble. That's a different problem.
Okay.
Can you explain how you got from the from green to the beginning of blue?
This one?
Yeah, or the 1 over
Okay. ln 4 is there, it's a constant. It's going to be in my problem in the end. So it was in the denominator, I'm leaving it in the denominator.
So you just like split it up.
What's the derivative of natural log of 4 times x?
Natural log.
Just the natural log of 4? Okay, so as a constant, it's just there. Do the
Natural log
derivative.
of 4 to the power of x.
Okay, I'm asking a different question. So this is some constant times x. What's the derivative of x? And then you multiply by the constant. This guy was just a constant. It was in the denominator, so I'm gonna just pull him out, push him over there for now, and then concentrate on this. What's the derivative of natural log of stuff? 1 over stuff. Chain rule times derivative of stuff. And now reduce things. That constant was still just there, just like it was here.
So you just plug the constant.
Sure.
And if the base doesn't have x in it, then you can always do that.
Yeah, I mean, if the, yeah. Okay, the things that cause problems. Moving targets. Can you guys try 43? Can we just multiply by the power and lower the power? No. Why not?
It's x.
Because it's from the x to the x. They're both moving targets.
Situation. No, not that. Okay, so the dt of x is a is a.
How do we start these?
So you do ln to both sides, well, yeah.
Yep, totally. Do ln to both sides. Why is that helpful?
Because you can just pull that x to the side, you know?
Because now I've taken the problem child and I made it product rule. So do that, do the product rule. You're not liking logarithmic differentiation.
You can't differentiate from natural log of y, because that would be y over 1. 1 over y, excellent.
And that's right, and then you gotta do implicit differentiation or chain rule.
Y, e, x,
There you go.
equals.
And if you forget the implicit differentiation, you've lost the thing that you were trying to calculate.
Equals x.
So, first times 1 over stuff times derivative of stuff plus second times the derivative of the first. Kelly agrees.
It's so disgusting.
Yes, ma'am.
I know, it's Friday.
It's Friday.
I thought we were. No, Miss.
About 20 minutes ago, I had.
Miss Pascal, it's 1 over sine x, not.
Monday.
Oh. Oh. Well, that just makes sense for all of us. Oh.
Okay, and, all right, so Annie did the product rule for us. She did first, left the x alone, and then derivative of this natural log, which is 1 over stuff times chain rule derivative of stuff, plus the second times the derivative of the first. And so I rewrote cosine over sine as cotangent. I don't know, they might not be able to be flexible in your trig functioning that you can rewrite things. Heather? Yeah, I'm not done.
Oh, okay, sorry.
You're right. Brooke, were you gonna say that too?
Yeah.
Okay, so just, and then dy dx wasn't by itself, so multiply by the y on both sides, and you guys are right, like, don't we need to get everything? Yes. Ew. Years of elementary school penmanship down the drain.
It's just cotangent x because it is now. Whatever. You didn't actually have to do 1 over u like we did before. We could just do you have to do chain rule now. It makes perfect sense.
It does actually, yeah.
This is kind of random, but do we have to like use brackets there, or can we just use brackets?
Okay,
Really nicer.
like, okay, for visuals for me, like, I used to be a programmer and there was so many round parentheses. It's nice to visually break it up, like, you could have just round parentheses, that's fine. But for me, it's more obvious to me where this phrase of stuff ends. So, no, you don't need to do square ones. Right? Try that one.
Oh.
I actually need to make the restriction more clear. Because they can't do, X can't be pi over 2. Or it can be pi over 2 or pi over 2 or whatever.
It's a real conundrum out there.
Why can't they put pi over 2?
Oh wait, I didn't mean to like think about what you said. Not, you can't put powers 2 because that's 0.
Tangent of pi over 2.
Undefined.
Oh, yeah, my bad.
I mean, you can do a power to 0.
But you can't do a power
Yeah.
of undefined.
Yeah.
Derivative of tangent. Nick, what's the first step?
You can take natural log of both sides. See.
What's the derivative on the left?
1 over y times dy dx.
Clara, is Clara, what's the derivative of this product?
Which one? Tangent?
Yeah, tangent L and X.
It would be tan x times ln x,
Derivative of L and X, which is 1 over stuff.
1 over stack.
So sorry.
And then plus ln x times negative secant squared x.
L and X times positive. Doesn't begin with C, so it's positive. And so this is tangent x over x plus secant squared x, natural log of x, and multiplying by y. I don't want to have to rewrite it again. Y was x tan x to the tan x.
Hey,
Okay, so, your tests, plural, Tuesday and Wednesday next week. Options, we can play with the calculator and try and like, just get some calculator skills so that you're more comfortable. Yeah? Okay,
Get a calculator.
2-day test.
2 days. Okay.
So 1 day of the test is with a calculator. So should we do calculator tricks? Yes.
okay.
There's a calculator draw for you.
Let's have to find the derivative of this.
That's correct.
This isn't really hard, I just have to find the derivative.
Right. So a lot of people are uncomfortable with using the calculator. That's the point of this, is to try to. Well, I think you do still need to do the derivative by hand, but
Would you need to do the derivative by hand? You can use a calculator there. What would be the point?
Well,
Just,
where do you? How, okay,
so you could put, you could literally put like the derivative of this as x approaches this.
okay, what x value am I plugging in?
Oh yeah. Well, there's also an equation solver on the calculator, so you can also do that. you wouldn't need to do anything by hand. Thanks for reminding me to read the question.
Yes.
I forgot step 2.
Yes, step 1, read the question, step 2, no, really, read it. But still, I'm fairly certain you need to do the derivative by hand for this.
How do you go to like where you get the y you want? Like where you put in y?
You hit the y equals, top left button.
No, like there's some way to like.
Oh,
copy
I know
and
what,
paste
yep,
type thing.
oh, copy and paste
Like
type.
not really. I don't know what it's called. But
And you have an 84.
yeah.
And again, the only emulator I have is an 83. So it'll look very different.
How do you find the zero after you
Okay. All right, so first thing, we want to know, find the x and y coordinates where the slope is. So I want to find when f prime equals 1. So Camden, what is f prime?
10x to the 4th minus 10x minus 4.
So I want to find when does this equal 1? And I would not do what they show you in Algebra 2, which is put this in an equation, put that in an equation, and find where they intersect. That's a pain and more complicated. So I'm going to subtract 1 to the other side, and I'm going to find where that guy is 0. Okay.
We would use the calculator.
What? Now enters the calculator. So hit in the y equals 10x to the 4th minus 10x minus 5. And then if I graph it, and the reason I suggest you doing this, like the number of you that will have 0, the x-axis centered. Okay, now it looks like it crosses at maybe -1 and +1-ish. Finding the zeros. Above trace, this 4th button, it says calculate. So if you hit second calculate, I want to find a 0. And here's one trick. Do you see it's blinking on the y-axis? I can move the arrow to the left, or I could just type in -2, and it moves it for me. So if you're far away from where you want it, you can actually just type in the x value that you want. And now there's that little arrow thing saying, am I to the left of that? Yeah. And I'm going to type in 0. And now there's these little sandwich bars. And it's asking, should I guess? Is this swipe? Is that where it crosses? Yes, it does. So say guess by hitting enter. And right there I have a value. If you hit second quit, if you type in X right now, it is the value that it just gave you. I'm going to store it in the letter A. So the STO button is store. Pick any letter you want. I'm not being creative. I'm picking A. All right, to find the other place, I'm going to go from 0, and then this time I'm going to use the arrow My y value went positive. I've crossed over. Hit enter. Now if I hit X, it's that new point, and I'm going to store that in B.
I find the weirdest.
Okay, so it said find the X and Y coordinates. I found the X coordinates. How do I find the Y coordinates?
Plug it back in the top, right?
Plug it back. Okay, here's a trick you probably don't know. This vars button, it's variables. I want the Y variables, the function that I typed in. Ooh, I did not type in the function. All right, in Y2, I am putting in the 2x to the 5th minus 5x squared, goodness, minus 4x plus 1. Why am I doing this? Well, vars, y vars, I typed my function in Y2. I want it to do Y2 of the x value I stored in A. Oh, go to. What? Oh, it's right. I did not. Do you know this second insert? I forgot the squared. And now I screwed up, but I can say second enter and it retypes what I just did. So there's my y value. And I can do second enter, bring it back, and tell me the y value at B. What was that x value again? Right there. So the coordinate negative 0.456, comma 1.744. How stupid is this? Because that will disappear in a second. X and Y coordinates where the graph is 1. So the one on the left, my A value was negative 0.456. That's truncated, and 1.744. And the other coordinate was 1.129, also just truncated. And the y value was negative 6.219. If I correctly rounded these,
Don't need to get any of this.
so you could have given the red answers or the blue answers. Yes, Sadie?
How did you get from